Isaiah is applying to be a carpenter. As part of the interview process, Isaiah has to complete an exam. He's already demonstrated he knows how to handle rational numbers like fractions. Now he has come to a practical exam where he has to prepare a frame for a wall and the drywall that will be hung on it. To do work like Isaiah is doing, it helps to know how to use geometry formulas. Isaiah is working with what is called plane geometry. Plane geometry is 2D, or two-dimensional. It is the geometry for flat surfaces, which may look like this. When working with flat surfaces, you are usually concerned with at least two numbers. What they are called doesn't matter, but they are often called either length and width or base and height. There are several important steps to working with 2D figures, called polygons, but the most important thing to remember is that you don't have to work this out on your own. A number of shapes have already been identified and have formulas ready to use for quick and easy solutions. By putting formulas together in the combinations you need, you can solve almost any flat shape before you start cutting. Perimeter is a measurement of the distance around a shape. In a square, all the sides are the same, so if you know one side, you can multiply it by 4 to find the perimeter. In a rectangle, the opposite sides are the same, so you can multiply the lengths and the widths by 2 and add them together to find the perimeter. Triangles are another common construction shape, and formulas for their perimeter are based on the kind of triangle being used. Equilateral triangles have sides that are all the same, like squares do. Because they have 3 identical sides, they multiply one side by 3. Isosceles triangles have 2 sides that are the same. If you know one of those 2 sides, then you can double it to get them both, but the third side has to be measured on its own. Scalene triangles have sides that are all different, so they will all need to be measured individually for their formula. Other shapes have their own formulas, but squares, rectangles, and triangles are very common in construction. Regardless of the shape, if you can find the number of sides and the length of those sides, you can add them together to make the perimeter. Formulas are there to help act as shortcuts. In this example, we are dealing with a regular hexagon. Regular means all the sides are the same. This means the perimeter of a regular hexagon is 6 times the length of a side, or 6s. If a shape is irregular, you have no choice but to measure each piece of the perimeter individually. There will be no simple formula. This is also a 6-sided shape, so it's still a hexagon, but because it's irregular, we can't count on the regular formula to help us find the perimeter anymore. Each side will need to be measured by itself. Solving any geometry problem is helped by breaking it into steps. Write them down where they're easy to see. Isaiah is presented with a problem. He needs to build a frame for a wall. The wall has to be 23 feet 11 inches long and 7 feet 11 5/8 inches tall. How much 2x4 will Isaiah need? Isaiah begins by looking at the shape he is dealing with. It's rectangular. This means he wants to use the perimeter of a rectangle. The formula for this is P equals 2L plus 2W, or P equals 2 times L plus W. The wall is described as 23 feet 11 inches long. That will go in for length. The wall is described as 11 feet 11 inches 5/8 high. When describing the room, they didn't use the word width, but Isaiah knows that the word used doesn't matter as much as what it does. This height is perfect to use for the width in the formula. With all the numbers he needs, Isaiah fills those numbers in the formula. He replaces the L with 23 feet 11 inches. He replaces the W with 7 feet 11 5/8 inches. Now he can do some math. Doubling both numbers using his knowledge of multiplication and fractions, Isaiah gets the following numbers. 23 feet 11 inches doubles to make 47 feet 10 inches. 7 feet 11 5/8 inches doubles to make 15 feet 11 1/4 inches. Now he can add these together to get the perimeter for the wall. He arrives at the figure of 63 feet 9 1/4 inches, which he'll use for ordering the correct amount of lumber he needs. Another task Isaiah is asked to handle is to calculate how much drywall he'll need for this wall. This wall is 18 feet long by 8 feet tall. Because drywall comes in standard size panels, he must also calculate how many panels he will need to cover the wall. Let's begin by considering what shape we are using. It's a rectangular wall, so we need the area formula for a rectangle. A equals length times width. To find the area of the wall that needs to be covered, we take the length of the room and multiply by the height of the wall, which will take the place of width in our formula. We check our measurements. Again, this wall is 18 feet long by 8 feet wide. Multiplying 18 by 8, Isaiah finds the area of the wall is 144 square feet. But the other part of the question was, how many drywall panels does he need? One way to solve this question is to see how much area each drywall panel covers on its own. The standard panel is 8 feet by 4 feet. As each panel is a rectangle, this means multiplying 8 and 4 to get 32 square feet. Since we're asking how many do we need, this is a division question. Each panel covers a certain amount of area, and we need to see how many will cover all of it. The panels are splitting the wall between them. 144 divided by 32 equals 4.5, or 4.5. We need 4.5 panels to cover this wall. Another way to solve this question is to ignore area and focus on the dimensions themselves. By rotating the drywall panels vertically, they are exactly as tall as they need to be. Isaiah only needs to count how many panels, 4 feet wide, fit into a space 18 feet wide. This is a division of 18 by 4, which is also 4.5, just like before. Another shape carpenters need to be comfortable working with is triangles, which are very common in roofing. In this case, Isaiah is faced with a set of joists that look like this from the side. He needs to make a panel that covers the long end, but he needs to know how long it is. When you are looking for the missing side of a right triangle like this, you use the Pythagorean Theorem formula. When you use the Pythagorean Theorem, the long side of the triangle is always C. The other two sides, called legs, can be called A or B. It doesn't actually matter which. Isaiah substitutes what he knows into the formula. The legs are 8 and 6. 8 squared is 64. 6 squared is 36. These add together to make 100. Now Isaiah asks, what number times itself makes 100? This is called rooting a square, or a square root. We're looking for a number that when multiplied by itself, like the 8 and the 6 were, makes 100. That number is 10. 10 is the square root of 100 because 10 times 10 is 100. Now Isaiah knows that the panel he needs to cut for the outside of this roof frame is 10 feet long. Carpenters also have to be familiar with circles. They may need to cut holes for pipes or ducts. They may make specialty windows and more. Part of the AdultEdMed construction plan calls for a garden for patients to recuperate in. And in that garden are going to be circular planters Isaiah will help build. These planters need to be 6 feet wide, but what Isaiah needs to build is the frame around the outside of the circle. So how much material will Isaiah need? This is a type of question called a circumference question. It's like a perimeter question, but specific for circles. Circles are special. They have a special number in common, called pi. Many measurements of circles depend on the radius, r, or the diameter, d. To find the circumference, Isaiah needs to take the diameter, or the measurement across the circle, which in this case is 6. He'll multiply that by pi. Pi is a unique number in that it doesn't terminate, it keeps going. But for most circumstances, you only need the whole number and the first 2 decimal places. So 3.14 will be enough for Isaiah. This means his circumference, or the length around the circle, is 6 times 3.14, or 18.84. If instead of looking for the circumference, Isaiah was asked to find the area of the circle, he would use this formula instead. Area questions require the radius, which is the measurement from the absolute center of the circle to the edge. Since the diameter, the distance edge to edge, is 6, this means the radius is half of that, or 3. Replacing the r in the formula with 3, Isaiah squares it to get 9. Then he multiplies by pi, or 3.14, to find a total area of 28.26. Now Isaiah has demonstrated that he can handle perimeter and area problems with several shapes like he might encounter on the job. Impressed with his math skills, the interviewer tells Isaiah he'll be happy to have him on the team. Starting immediately, Isaiah is now ready to join the team building AdultEdMed.